All right, another friction example. A ladder is placed against a wall as shown. So it's like an extension ladder. Assume no friction up at the top at B. Just to make the problem simpler, if there's friction at the top and bottom, it becomes a much harder problem. And the friction at the bottom would be a much more significant number because that reaction would be greater. But anyway, again, no friction at B just because I said so. However, there will be friction down here at A. There's a 200-pound person climbing up the ladder. They need to climb to a point that is 6 feet above the ground. Will the ladder fall in that orientation? Okay. Mu s over here is 0.3 at A. Again, it's frictionless up at the top. The ladder is 10 feet up, 4 feet out. This is one of those cases where we can't assume the friction force to be equal to mu s times m. We don't know what it is. What we do know is that it's got to be equal and opposite to this force up here, this reaction that's going to develop at B, because isn't that the only other force happening in the X? That's why drawing a diagram is so helpful. We have this one pushing to the right. It's normal to the surface, right? There's not one in any other orientation because there's no friction up there. We have this 200-pound force acting down. We need to solve for the distance because we're going to sum moments about A. So it's 4 feet all the way across. Using similar triangles of 10 over 4 is equal to 6 over what? We know that this horizontal distance here is 2.4 feet. So then I can sum moments about A, so down here, equal to 0. I can solve for R sub B, and that's going to be 200 pounds times 2.4, that's the person on the ladder, minus RB times 10 feet, that's the reaction at the top of the ladder, equals 0. That means that RB has got to be equal to 48 pounds. What's the reaction RAY? That one's pretty simple if you think about it, because it's just you can do sum of forces in the y equal to 0. So that's going to be 200 pounds. And we actually know F sub F as well, the friction force now, don't we? It's not equal to mu s times n. It's got to be equal to 48 pounds. As long as 48 pounds is less than mu s times n, it actually isn't going to slide. That's what we're going to check in this problem. So looking at sum of forces in the X, we can see that friction force, as I said, is 48 pounds. The vertical reaction is 200 pounds here. So now we know the normal force. We know mu s. We can calculate that maximum friction force and see if this actual friction force is less than it. So how do we do that? Well, 0.3 times 200 pounds is 60 pounds. That's the maximum friction force that can occur. And we only have 48 pounds, so the ladder will not fall.